I'm sure most of you know Chris. Chris is from Netherlands, now lives in Germany. He's the one who brought his family. I don't know if he's worried about his kids screaming or not, but if they do, let's all help out. Yeah, but I think you seem ready. No?
I think I'm
soon?
ready. Good morning.
Good.
Buongiorno.
Good, good. Well, jonge dame, Chris Eidhof.
Yes. Hey everybody, it's so good to be back. If you want to know how many trains we took, ask my oldest daughter. She'll be happy to tell you in English. Let's see if we can get the clicker thing working. If not, we don't need it. So my talk is about SwiftUI animations, and I want to show you a way to visually think about these animations and how SwiftUI works under the hood. I think that's very helpful. So I work at Objective-C.io, and I have this new project called the SwiftUI Field Guide that you might be interested in. But I want to talk about animations, obviously. And there's so much we could talk about. There's so much to cover. So the theory of animations is actually really interesting. If you want to know more about that, like it goes all the way back to Walt Disney and his people putting out stuff about how to animate stuff. And there's so much more. Like easing curves, you could talk about continuity, about interpolation, which we'll briefly cover actually. There is the topic of animation design, which is a really big thing as well. Again, we will not cover that. But then we will look actually more at how SwiftUI works and how its built-in animation system works. So for example, the dot animation modifier, which mostly is really cool, but then it has some kind of weird behavior sometimes. There's the with animation modifier. There's problems when you start using dot animations, these implicit animations. And we'll briefly touch upon that as well. And then you can have custom animatable views and modifiers. You can have transitions when views gets inserted and removed. There are phase animators and keyframe animations. And finally, there's stuff like timeline view in Canvas. And let me make it a little bit bigger. There's only so much we can cover, right? But we'll actually mostly focus on these topics. We'll look at the built-in animations and see how they work and how they work visually. And hopefully, that will be helpful. Okay, let's see. Okay, so let's see if the clicker still doesn't work. No. Okay, no problem. So we're going to build a little toggle control to start with. And here we have a capsule. We can add a frame to make it a little bit smaller. And then we're going to fill it to make sure we have a nice background color. And so this toggle, to be a toggle, we need, of course, like some kind of indicator as well. So we'll add a circle in an overlay. And because it's in an overlay, it will become the same size as the switch. So we don't need to specify any size there. We can add a little bit of padding to inset it a little bit. And then we want to leading align it. And this already looks like a switch or like a toggle in the off state. The next thing is that we want to add a tap gesture to make it interactive. And normally we would pass in maybe an is-on binding. We're going to add a state property. And we can now try to tap it. Of course, nothing happens because we're not using that is-on property. So let's make use of it. So we can change the background color or the fill color of our capsule depending on whether we're on or not. And so that works. We can go and switch between trailing alignment and leading alignment depending on the state. And now we basically are done with our toggle. So this works. The thing is, though, that our toggle is not animating. And this is actually, you can almost, like, it's a very profound thing, right? Like, what does it mean to animate? We are going between the off state and the on state, and yet it doesn't animate. And what does it mean? Like, what does that mean for a view to animate? So we have our state before and we have our state after. And if we just switch between the two states, it's not animating. So how do we animate? Well, if you think about it, let's say we want to animate over the duration of 1 second. We kind of want that green to fade to gray over the duration of 1 second. And we kind of want that circle to move, right, between the two positions. But what does it mean to move something on screen, right? Like there is no movement really. And so the computer, of course, draws these frames 60 times per second, or maybe 120 times per second. And so over the duration of that 1 second where we want to animate, we need to draw all the positions in between, right? We will need to take our start position and our end position and draw the circle at all the positions in between. And you can do that by taking the two positions and interpolate between them. That's the technical term there. And so luckily, to do this in SwiftUI is really easy. We just say dot animation is in out. We say we want to animate when the isOn value changes. And now if we tap it, it animates. And so it's really simple. And a lot of animations in SwiftUI are very simple. But I was very frustrated when I first saw this. And I was like, how can this possibly be, right? Like it's too easy. There must be either we'll run into limits very quickly if it happens automatically, or this is way too magical and nobody will ever understand this. Like, I enjoyed that it's just a single line, but how could this possibly even be so easy? And I think this is where it really helps to have a look into the visual debugger. So let's open it up. Move over my mouse. Okay, so this is a new version of Instruments, unreleased, hopefully next year. And here we can see the render tree. And the render tree is what SwiftUI keeps in memory. It's a persistent tree, much like the UI view tree. We never deal with this directly. You can sometimes see it as the attribute graph. I call it the render tree. And here we have nodes for all the things we wrote in our program. And we can go back to the last state update and step through the changes. So the isOn is going to change to false, which will cause a redraw of our root view. That will cause a redraw of the tab gesture. And that will cause a redraw of its child, the dot animation. And you can see here, in between the two nodes is this weird symbol. This is the current transaction. The current transaction contains information about the state change. And the weird symbol means that the current transaction is empty. So we can go to the next node, the animation, the value changes, and SwiftUI now knows to add that animation to the transaction. And so the entire subtree will now be animated, any changes in the subtree. That's what the dot animation modifier does. If you use with animation, it adds the transaction, or adds the animation to the root transaction. But that's what's going on under the hood. So let's scroll down a bit here. So it starts updating the frame, which didn't change. It starts updating the overlay, which changed from trailing to leading. And SwiftUI will not animate that per se. So there's no animation happening from trailing to leading. The only thing that this overlay will do, or the alignment change, is that it lays out its subviews differently. So we then hit the tuple view, which has the two children, and we hit the capsule. And you can see here that the capsule has 5 properties: X, Y, width, height, and the fill. And these properties are written in italics. And that means that we can see that they're animatable properties. So what will happen is, in this case, the fill will change, right? And so SwiftUI will attach an animation here to our fill color. And we can see over the time of 0.3 seconds, it will go from green to gray. The gray is a bit hard to read here. And then if we continue, we hit the padding node, and we hit the circle, and the circle will actually have its X position animated. And so there we can also see this timing curve. And so these animations are sort of attached to individual properties of the views. Okay. So that seems easy enough, right? And now we need to look at the more complicated cases. Okay, so here we have another circle, and we're going to just animate a bunch of properties and then see how we can interact with that. Okay, So let's add a state property just like before. We'll add a tap gesture just like before, toggle that state property, and now we can, for example, change the fill color. And so if we tap it, it changes between blue and red, and that's fine, and it's not animating. So we now know we can just add dot animation, and magically it now animates. So if we now tap it, it animates, it changed perfect. Then we can change, for example, the width. And you can see it now changing its color and changing the size, and it happens synchronously, and it's very easy so far. We can animate the alignment between leading and trailing. If we do a max width infinity, that means take up the entire proposed width. And so if we now animate it, this is perfect as well. This is exactly what we wanted. But I told you before how this dot animation, it animates the subtree. So the subtree of the dot animation would be the frame with the max width infinity, the frame with the width, and the circle. So if we take that into account, that would also mean if we move the dot animation upwards and apply it to a smaller subtree, only those properties should animate, right? So let's try that. And this confused me for the longest time. So reading the code like this, the subtree of the dot animation would be just a circle, right? And I would think that the size and the position of the circle should jump immediately, and the color should animate, which is not what's happening. Everything animates just like before. And this really confused me in the beginning. So let's move it back and then look at why this happens. So let's open up our view debugger here again. So it's the same example. And here we can see we have our circle example, and let's go back to the previous state change, go over the steps, we change to false, some stuff changes, and then we start updating our views. So we hit our tap gesture, we hit our dot animation, and we get an animation in the current transaction. Then we get to our frame, a bunch of properties change. We get to our next frame, a bunch of properties change, and then we hit our circle. And you can see that the circle has the x, the y, the width, and the height in italics. So the animatable properties are part of this leaf view, and that's always the case with the leaf views in SwiftUI. This is why if we would move that dot animation node that we have up here, if we move it to right above the circle, it would still animate the x, the y, the width, and the height. And so that's why previously we couldn't turn off the animation there for that subtree. And so when you work with animations in SwiftUI and when they don't behave like you think they should, it's always really important to keep in mind what are the properties that are animated and to which modifiers of views do these properties belong. And it's not always the case that you cannot turn off animations, but in this case, it is. One thing that's really cool, by the way, in SwiftUI is that you have these interruptible animations. So you can interrupt an animation right in the middle of it, and SwiftUI will do this correctly. And actually, we can have a look at the timeline for this. So if we go back, I'll zoom out a little bit, to the timeline, and maybe to the start of the last event, scroll down. You can see here that we had our animation going on, and then we tapped again, and it starts animating in a different direction, and we tapped again, and it starts animating back. And SwiftUI will take care of this for you. So it will always have a single animation attached to a property, for example, an animation to the X property. And as you interact with it, it will replace that animation with the new animation. Okay. Let me close the debugger. Now, let's look at an example where moving the dot animation does work. So we have a rectangle, we fill it with green, and we add our state property like before, we add our tap gesture like before, nothing is happening, right, because we don't use that state property. And we can add a scale effect, and scale between 1.5 and 1. And so now if we tap it, it scales, it's not animating, but we can add our dot animation, and everything now magically animates. So this works as expected. Here, we can control the scope of the animation by the position of the dot animation. So if we move the dot animation upwards to after the rectangle, now if we interact, we can see that it doesn't animate. So now the animation actually applies to the subtree. And this is because the scale effect has an animatable modifier, animatable property. So let's move it back, and then let's have a look at the view debugger. So again, this works. We can look at our render tree, and we can see here, if we scroll down, we can already see that the scale effect has the value in italics. So what happens is, let's go back to the start of the previous change and step through this. Start of the previous change. We can open up our timeline here, and you can see if we scroll to the timeline that the scale effect, as we go through it, you can see this in the render tree as well, that the scale effect property will slowly go from 1.5 back to 1 and back. So most of the modifiers in SwiftUI do work like this, but you have to sort of learn, and it's trial and error. But now you know how you can test that. Just by moving the dot animation up and down, you can see whether the modifier you're working with has animatable properties. Okay. So those are the basic implicit animations, and you can work with those and play around with those, and mostly they work. And as I mentioned, like often when you have something that you want to animate, you can just say dot animation and it will work. But then if it doesn't, you need to understand exactly what's going on. Let's look at another example. Here we have a green rectangle, and it's filled with, right? And so we can add another frame here, make it 100 by 100, and add a tab gesture and toggle something. Nothing is happening yet. What we want to do is animate the insertion and the removal of this rectangle. So we can put it in a VStack, put a second capsule on top of it, and make it blue. And now we have something we can tap. And we can add an if condition around the rectangle. And you can see, because isOn is false by default, the rectangle doesn't show up. The moment we tap it, it does show up. And if you're trying to understand SwiftUI in terms of UIKit, what's actually happening is, as we make that state change, SwiftUI re-renders the body of our view, and it will insert this rectangle into the render tree, almost like an add subview. The moment the condition changes back to false, it will remove that view from the render tree, also like a remove subview. And this is very important to keep in mind, because as the condition changes, any associated state for that view will also go away. Any animations that we're running will also go away. But the cool thing is that we can also animate these changes. So for example, we can say animation is an out, just like before, and magically it animates. And my preferred way of debugging these kind of animations to see what's going on, beyond just clicking things, is creating a QuickTime recording and then playing it back frame by frame. It's the most high-tech solution I know of currently. But if you were to do that, you would really see, and you can verify that it's fading in and fading out. And that fade, or actually the opacity transition, that's the default transition for inserting and removing subviews. But you can control this. So you can say dot transition scale, and now the view scales in, which I think is much cooler. And there's a bunch of built-in transitions, so you can really go full PowerPoint. And you can also create your own transitions. So you can create any view modifier and turn it into a transition, or create a transition out of any view modifier you have, which can be super helpful. You can, just to show you, you can also combine transitions. For example, you could add a scale combined with an opacity, and now it fades in and scales in. And it's really fun to play around with this. When we do this in workshops, people go crazy with all the possibilities. Yeah, it's really fun. So again, let's have a look at under the hood what's happening there. So this works just like before. We can open up our render tree, and we can see now that we have this tuple view, like the children of the VStack, right? And the first child is there. the frame with the capsule, and the second child is just an empty if. There's no second view. And the moment we tap it, the view appears, and if you look closely, you could briefly see the animation attached here. We can go back in time actually and see what happened there. So let's go here to the start of our animation. Scroll down a little bit. So here we can see that the opacity, if you look at the far right, you can see the opacity starts at 0, and as we go through the animation, it will go all the way from 0 to 1. Let me zoom out. So you can see the scale effect as well. And so the scale effect, same thing, it goes all the way from 0 to 1 as we insert and remove. And yeah, so these transitions are basically modifiers that are applied to the views while the view is inserted or removed. Okay. So we got our animations covered, we got the weird behavior with the dot animation, we got our transitions. And now let's look at the final example. So what happened so far, I think, was really cool. We had our state change, right? And we had our view tree before the state change. We have our view tree after the state change. And SwiftUI sort of magically interpolated all kinds of properties for us, and that made it look really nice. So maybe a different way to put this is we had our state A of the view tree, we had our state B, and SwiftUI animated for us from A to B. And we just added a dot animation everywhere, and things magically worked. But what if you want to animate from A to A? For example, with an imperative animation system, this is very easy. What if you want to shake that view when you tap it, right? It's the same state before and after. Like, how would you even do that? Maybe with completion handlers or something like that. And all of that is not necessary. And actually knowing how to do this the proper or the built-in SwiftUI way teaches us about how the animation system works. Okay, so we're going to make a shake animation. The first step is to add a state property. You always need a state change in order to start an animation. And then we're going to add a tap gesture to increase those number of taps. It's stored off as an integer by default. And then we're going to create our custom view modifier or shake modifier. So this has a body, and it just displays the content. And to verify that it's working, let's add an offset of -100. So our view is still centered. And we need to, of course, use our shake modifier. So let's do that. So we can add the modifier in here. And now we can see that the circle is drawing 100 points to the left. And then we need to pass the number of taps to our modifier so we can animate that. So let's do that. We pass it in, and we also need to use it now. So maybe we wanted our circle first to move to the right by 10 points every time we tap. Of course, we need to pass the number of taps to our modifier, convert it into a CG float. And now I think if we tap it, it moves by 10 points to the right every single time. Let's add a print statement so we can see exactly what's going on. So we can see now that it prints 0. And so if we tap it, it will move to the right, and every time it prints a new value. And then, instead of just printing it, we can also animate this change. So we just add our .animation modifier, and now if we print it or tap it, you can see it still prints 0, 1, 2, 3. But it is animating 10 points to the right? Like it's a smooth animation. And I think what we really want in order for this animation to work is if we can get that number of taps property, if we can get that animated for us by SwiftUI, then we can feed that into a sign function or something like that to do whatever we want with it. And so the way to do this is to make your view modifier conform to animatable. And that tells SwiftUI, hey, I have this thing in my render tree, and I want you to animate certain properties of it. And so the first step is to conform to animatable, and the second step is to say which properties you want animated. And you do this by creating animatable data. And in our case, we just want a single float to be animated, which is the number of taps. And you do this by providing a getter and a setter. And Now, it's very interesting. If we tap it, we can see in the console, let me scroll up a little bit, that it printed all these values for us, right? During the entire animation, which was, I think, 0.3 seconds, it printed all these intermediate values. And so SwiftUI knows how to do this for floats, and it will just hook into the animation system and says, like, okay, for every frame of the animation, I'm going to find like an interpolated value all the way from the beginning to the end. And what's interesting here, if we scroll, you could see here in the middle the interval between the different numbers. So each number represents a single frame. So it's 0.4 here, or 0.04 from 50 to 54, from 54 to 58, again 0.04. If we scroll all the way to the bottom, the interval between the numbers is much smaller. The last three are 0.99. This is because we used our ease in out curve. That means start slowly at the beginning, go fast in the middle, and then become slow again. And so we can change that as well. We can change it into linear, and if we now print it and scroll up, you can see that the values are spaced much more evenly. And so a linear curve is just a straight line going from A to B. And this goes all like into animation theory. For some properties, you want to have ease in out for things to look natural, because if you have a physical object that moves, that sort of starts and gets a velocity and all of that, and other things you want to move in a linear way. For this animation, we want to feed that animatable data into a sine wave, which already is curved, so we'll just stay with linear, and now add our sine wave. So now, we changed our offset to use the number of taps times 2 times pi, and if we tap it, I don't know if you can see it, it shakes by 1 point to the right, 1 point to the left, and back. And so we can increase the amplitude here. So we can say times 30, and now we actually have our shake. And I think it's helpful to, again, look at the render tree and see what's happening there. So let's verify that it works in our new instruments version as well. And go to the start of the previous. Let's open up our timeline, go to the shake modifier, and we can see as we now step through the animation, the animatable data of our shake modifier now has a linear curve. So that's just a straight line rather than the ease in out curve we had before. And as we just go through time, that value will increase, which causes the body of the shake modifier to re-render, which causes this offset to change. So let me go back to the beginning. And if you look at the offset, it goes all the way up, and then goes into negative, and then goes all the way back to 0 towards the end of the animation. And this is the complex way of making that shake happen. There's actually a much simpler way using phase animators, which is basically a set of completion blocks attached to each animation. But phase animators don't teach us as much. So that's why I did it this way. There's so much more to animations, and specifically phase animators and keyframe animations would be super useful in your daily use as you're building SwiftUI apps and as you want to animate them, and I would definitely recommend looking into that. They build sort of on top of this existing system. This is the core of SwiftUI animations, and then there's just a lot of stuff added on top. I wish I could talk about a lot more things, but unfortunately our time is limited. So I'll see if I can get to the end screen. Yes, I'm very happy to take any questions, either now on stage or afterwards, and thank you for listening. Thanks.
Thank you very much, Chris. Do we have any questions?
Are you going to do the running to the S?
No, I'm supposed to stand on the cross.
Hello.
We have a question over there.
Yes. Hey, thanks for the talk. I am super curious about what tool did you use to write the code and see the render tree along with the animations?
Yes.
And where we can get it, if we can.
It just works on my machine currently. So it's just SwiftUI with a text view, and I recorded the keystrokes and then play them back. And in theory, I can walk around on the stage and press next, and it types for me. But for some reason, the clicker didn't work. But it's just a text view that plays back old insertions and removals.
Okay, and do you have any plans to release it? Or-
It's kind of like with open source, because with SwiftTalk we always open source. We put the code we write on GitHub, and open source is, if you actually open source a project, it's a really different thing, right? Like you take contributions, you build a community, you take care of the community. We are super bad at that, and it's the same with this tool. It looks very intimidating if you don't know what buttons to press, or I do know what buttons to press, but if I come back to this in a few months, I have no idea how any of this works. So yeah, no, it's currently, I don't think it makes much sense. It's way too complicated, and it would take a lot of time to improve it. It's smoke and mirrors.
Okay, thank you.
You're welcome.
I think we had maybe one question in front here, or wait for the mic. Yeah.
Hello. So, assuming, because I'm a blind developer, so this is of great importance to me, when I animate, for instance, an integer or a double or any other value, is there any way, any programmatic way I can go over my animation frame by frame and see, let's say, the value, the current value that's being animated? So for instance, can I, for instance, see that, let's say, frame 30, when I animate from 1.0 to 2.0, can I see that frame 30 is at, let's say, 1.5 or 1.3? Is there any such way?
Not really, unfortunately. So what I mentioned is my basic technique of debugging animations is to do a QuickTime recording, which is, I imagine, almost completely inaccessible. One thing you can do is you can create your own timing curves. You can create a timing curve that's always at 20% of the animation, or a timing curve that's always at 21% of the animation. And that way you can see sort of like, where is my value halfway through the animation? It's a big hack, but it is possible to work with that a little bit. If the integer was on screen, you can definitely do it. Another thing you can do is for the custom animatable properties, you can print out the values and then you could read it in the console. But it's super hard to debug these things, and it becomes even harder, unfortunately, when you have to deal with accessibility as well. So I don't have a good answer, and the short answer is yes, there are some possibilities, like some hacks that you might help you a little bit, but this definitely needs a lot of work.
Because I tried to experiment at some point with representing animations as Swift charts, because then it allows me to play, with the audio graph, but it doesn't kind of work.
Yes.
But I thought that there's a better way. Thank you nonetheless.
Yes.
Yeah, we have another question over here from the handsome guy in the front.
So 2 quick questions. One, is it clear to us which properties are animatable in a SwiftUI view?
Sorry, what?
So with circle, you said these properties are animatable. Is
Yes.
that clear in the docs?
No. So the tool I showed was a future version of instruments, hopefully. And hopefully in that future version of instruments, there will be an accompanying doc set that contains information about what properties are animatable and what not, and maybe also how the layout system works, how the animation system works. So no, it's not documented.
And when you moved the animation up, if we'd wanted to say, I don't want to animate some of the properties, is there any way for us to say, don't animate?
Yeah, so moving the animation up is doing that, but then some modifiers work in a different way, right? Like the frame, we are telling, like, we don't want those properties to be animated, but then they still animate because of the way SwiftUI is implemented. And Maybe one sort of shortcut or one way to think about it is specifically the position and the size of a view is very hard to control from the outside because it's at the leaf node. So because it's a leaf node, by definition, any animation modifier will be above that leaf node in the tree or down in the code. So it's really hard to not do that. One way to do it is maybe with a custom view that you conform to animatable, but this is a real pain point if you want to fine-tune your animations and make them perfect. It's really hard to get that very precise control over certain properties, and those are very important properties. Yeah, thanks. Great question.
Do we have a last question?
There's one over there.
There's one over here, yeah. We can do the other one after one as well.
Hi. And there is any problem to add with animation in the view model?
Yes. So we saw that the dot animation takes the current transaction and sets an animation whenever that value changes. What the with animation does, it starts at the state change and directly sets the animation in the transaction. So as SwiftUI starts updating the tree, it will already have an animation. This is really useful because it lets you sometimes animate certain changes and not others. For example, let's say you load some data from the server, you might want to have that animated, but if the user interacts, you don't want to have that animated. So then you want more fine-tuned control over where you put your dot animation, or instead you might want to use a with animation. There is no problem in theory with putting with animation in your view model. It's necessary often, but it might be harder to test that way, right? Like it might be harder to break it apart and test that you're actually animating stuff because there's very little infrastructure for debugging animations, as I also just mentioned, and it's the same for this kind of stuff. But no, it's very possible, and I do it all the time. But maybe in a larger team, you'll have issues with testing. I only work in tiny teams, so I never have. I don't have that much experience with real code, you know. Like I just make toy projects, but and I know how SwiftUI works, but I don't know how to apply it in like a big project and what the limitations are there.
Good. Let's do a last question over here. And a short answer as well.
Hi. So my question was actually the same like with animation view model. And yeah, now I have another question. Should we use transitions with animation always, or is it possible to use transition like separate?
Yeah, so let's see if we can do this. I'll try to make it very, very short. The code is on GitHub also. If we go to our transition example, we can see that this works. So this is the same example. The moment we disable the dot animation, it's not going to animate anymore. You need that. You need a state change to cause a re-render of the body. You need a dot animation to animate everything down below. And if you leave out the dot animation, your transition will not work. There's a few more complicated things with transitions. And I'll leave you with this one completely out of the blue remark. If you have a problem with your transition, for example, over here, try putting a Z-stack around your views. That's it. Thank you.
Very much.
Thank you very much, Chris.